Hi, welcome back. We're going to continue our discussion with comparing the derivatives, and we're going to start off with kind of a little bit of a warm-up I like to give my students. And we are trying to find the signs of the derivative and the first derivative at x equals a. And we can do a lot of this just by looking at the graph. Remember, in this case right here, we are going to be given the graph of the function itself. And at point A, we want to know what's happening with the derivative and what's happening with the second derivative. More importantly, what are their signs? Remember, when we talk about signs, we're talking about positive or negative, zero in some, or zero, I guess we can probably take a look at. So for the first example, notice if we're looking at the derivative today, that this has a positive slope. So because it's going up, it's an increasing slope. So the slope here is positive. And I'm going to go ahead and write down the reason, and that is because the function itself is increasing. It's always good to have this. You don't have to have this for your answer for like a test or a quiz, but for notes it's always good to have this because it's going to help you review. What about concavity? Well, if I look at it, this is concave down. This is opening down. So that means the second derivative has to be negative, and that is because the function is concave down at that point. So let's go and go to number two. Number two, we are looking at the slope. The slope at A, it looks to be negative because this is decreasing. So we say that the slope is negative, and that is because the function is decreasing. What about concavity? Well, this looks like it's opening upwards. Now another way we can tell it's kind of concave up if we want to is if we look at the derivatives. Notice I'm starting at way negative, and we talked about concavity with the second derivative. If a function is concave up, if as we move to the right, the slopes are increasing, and they are. I'm starting at way negative, and my slopes are going towards zero. So this is positive, but most people don't remember it that way. They just look, it looks like it's a concave up graph. And that's the best way to look at it, because the function is concave up. All right, number three, notice we have a line in this case. And so if we look down right here, this slope looks like it's negative because it's going down, yep. So this would be negative, and again, that is because the function is decreasing. But my next one, my favorite one by far in this page, what about the second derivative? Remember, we're looking for concavity. So if we look at this, this is a line. It's not concave up or concave down. So there are two answers we can pick. We could pick D and E, because it does not exist. There is no concavity. Or we can pick zero. Well, so either one of these will work, and we'll take a look at both of them in a second. In either way, the reason for this is because there is no concavity. When we look, so one way we can look at D and E, because it's definitely the concavity does not exist here, it's not concave up or concave down, but if we look at this in terms of a line, for example, let's think about the line y equals 3x. This is a straight line, just like we have on number 3 right here. If I take the first derivative, we're going to get 3. But when we take the second derivative, we get 0. Remember, my second derivative determines concavity, and the second derivative is 0. This has no concavity with it. So therefore, that's how we get no concavity. Remember, we had a special name for this? That derivative annihilator. Derivative annihilator. You have been annihilated. Okay? Alright, so just some really quick examples. So let's take a look now at how we can get some derivatives from a table. We saw some of these earlier this year, how to get the derivative from a table. So let's see if we can do these. This is pretty challenging because if I'm looking for a derivative, we normally use a function, but from a table we actually are using we're going to use just pick 2 points. In other words, in order for us to get the slope here, we're actually going to use the average rate of change to approximate the instantaneous rate of change. Remember, the derivative says I want the instantaneous rate of change. But because I'm given a table, we're going to use the average rate of change. So remember AROC, we should remember this formula. F of B minus F of A over B minus A. So if I want to estimate the slope at 1.3, I'm going to use the points around it. So here's 1.3. I'm going to use points around it. So to estimate this, because I'm estimating using my squigglies, I'm going to look at the slope of 1.4 minus the value at 1.2 divided by B minus A, so 1.4 minus 1.2. Remember, change in y's over your change in x's. Well, the bottom is easy. That's just 0.2. The top, we're going to get 2.9 minus 2.8, which is 0.1 over 0.2, or 1/2. So the estimate for the slope at 1.3 is about 1/2. So let's go and try to do 1.5. Same idea for 1.5. I'm going to use the points around it, 1.6 and 1.4. Now, you can use 1.5 and 1.6, or you can use 1.5 and 1.4. That's just your choice. I always prefer to go around the point I'm looking for, if I can. So we're going to get f of 1.6 minus f of 1.4 over 1.6 minus 1.4. And again, looking at the values, this is 2.8 minus 2.9 over 0.2. And that becomes negative 0.1 over 0.2, or negative 1/2. Very quick and easy. Remember, this is our average rate of change. Alright, so here's the next one. Now we're being asked to estimate the second derivative. Now from a table, pretty challenging. So let's talk about how to do this. A quick way to remember is that this is going to be the average rate of change for the derivative itself. So if I think of it that way, it's a little bit easier to do. Other names, it's the slope of the slope we've been talking about, or the change. The second derivative is the change in the derivative. How is the derivative changing? So to estimate this, I want to estimate the slope of the slope, or the concavity, at 1.4. So again, I'm going to pick numbers around it. So it's the change in the slope. So it's going to be f prime 1.5 minus f prime 1.3. Notice, up here, to get my derivative, I looked at the change in the values. To get the second derivative, I look at the change in the derivative. And it's still going to be over 1.5 minus 1.3. So I need those values. Look, we just found them already. Remember that? Look at this. The f prime 1.5. Again, the test, the AP, they'll lead you into all of this. They're going to give you everything you need. So f of prime of 1.5, we know is negative 1/2, minus f prime of 1.3, which we said was also 1/2, over 0.2. So that becomes negative 1 over 0.2, which is, what's that? If I move the decimal over, negative 10 over 2, or negative 5. Very good question. Very good. Now, other questions we could ask on this, okay? These are good things to know for a test with the AP. One, what's the concavity? Is it concave up or concave down at x equals 1.4? 2, I could ask if f prime of 0, if f prime of 1.4 is 0, is f of 1.4 concave up or down? Other type of questions I could ask. What if the first derivative at 1.4 is, or if that was 0, is this a maximum, or is it a minimum value? So other questions we could ask. Alright, well that's all the notes for today. So I hope you guys had fun. I'll see you guys later. Bye-bye.